This tutorial will illustrate a few of the modal analysis features available within SAP 2000. SAP 2000 offers several different ways for defining masses. The masses used in the program are typically available from object material properties, applied loads, or assigned masses. For the first option, the define material command allows us to specify a weight per unit volume for each material type, which the program divides by gravity to calculate a mass per unit volume. The mass per volume is multiplied by the volume of the objects and then lumped by the program at the joints. One of the unique features of SAP 2000 is its ability to calculate mass from applied loads. Only loads in the negative z direction may be used to calculate mass. If this option is selected, the load will be divided by gravity and applied as a mass in the x, y, and z directions. In these units, a load of 32.2 applied in the minus z direction would result in a mass of 1. Added masses may also be assigned, in this case to the middle level joint objects, via the assign joint masses command. We will assign mass in only the global x direction. The define mass source command specifies where the program should find the mass, from the elements and assigned masses, or from loads, or from both. If loads are selected, the user may apply a multiplier. Note that the loads will have already been divided by the appropriate gravity factor. This example will use the element and added masses. We will not use the loads. The define load cases command lists the load cases. Select the modal case and click on the Modify Show button. Here we can specify the type of analysis, in this case modal, the type of vectors to be used, eigen for this tutorial, the initial conditions, and the number of modes to be generated, which will be set to a maximum of 2. For this analysis, we will restrict behavior to that of a planar frame. We are now ready to run the analysis. We will set the dead load case to do not run, as we wish to do only a modal analysis. Once the analysis is complete, the first mode shape is displayed. A click on the toggle button brings up mode 2. In addition to the graphical display, tabular results are also readily available. Go to the Display Show Tables command and check the Joint Output box, and then click on the Modify Options button. Here we can set the number of modes to be displayed from all to just the first. On the mass table, note that for our 3 middle level joints, the mass in the U1 or X direction is greater than that in the U2 and U3 directions by a value of 1. This is where we added the mass. Go back to the Display Show Output Tables command Uncheck the joint output box and check the structure output box. Click the Modify Options button and select All Modes. The table of modal load participation ratios shows that we have full participation in the X direction, but that additional modes are required to capture the Z direction response. This concludes this tutorial on mass and modal analysis.